Go and open your book to page 125. Today's lesson is on graphing for trigonometric functions. So first, let's go over the sine function. So you have y equal to sine of x, and okay, so we're going to learn how to graph this. So if you look on page 125, this is a function. Function is like a machine. So this is your input and this is your output. So you put in the x and you will do the function and it will give you the output. Okay, so when you're doing the graphing, again, just like the regular graph, okay, you're going to have the x and the y and you just plot the points. So x is the angle. So this is like your angle, the theta, and this is like the vertical, right? So if you go side by side, you can see it more clearly. So that's your x, and this is a y. So when at angle equal to 0, right over here, right? So x equal to 0, the height is 0. Now when you get to this angle right over here, so that's over here, right? So the height, you just go straight across. So at that point, when x is over here, the 30 degree, then the height is over here. And at 45 degree, right over here, okay, so you just go straight across. It's going to be like right over here. Okay, and then at 60 degrees is right about here, and it's going to be going across right over here. Okay, and then you keep going. So at 90 degrees, about right over here, you go straight across. That's the height. So it's going to be right over here. And so and just continue on with each dot. So like right over here, it's going to go down. So when you connect all these dots, you're going to end up something looks like this. Okay. So again, like right over here, this is going to be right over here. See this point? It's going to be right over here, and it's going to be like this. So basically, what you do is just go and plot the points, and you just transfer it over. So again, here's your angle and the height. So the angle, the height, and you do that, you're going to get this graph. So if you look on page 127, so that is the graph for the sine of x. And do the same thing for cosine, okay, and tangent and all the graph. You do the same thing. So if you look on page 131, so on page 131, so this is the sine function. And page 131, you got y equal to tangent of x. So that's the graph. Okay, we're missing one. Oh, okay. So page 128 is y equal to cosine of x. And so you got all these graphs. So those are your basic graphs that you need to be familiar with. Okay, so page 132, you get y equal to cotangent of x. And when you get to page 133, you have y equal to cosecant x. And also you got y equal to secant of x. Okay, now when you're graphing so if you notice that when you have the y equal to cosecant of x, notice these are reciprocal, right? So the way to graph the cosecant is you graph the sine first, and then what you do is just take the reciprocal. So you just put 1 over each of these points. So notice over here is 0, right? So 1 over 0 will give you undefined. So you're going to get asymptote. Okay? Again, over here, the y is, so it's 0, right? So you take the reciprocal, 1 over 0 is infinity. So that's how you get these, right? And rest of them, like over here is 1. So 1 over 1 is still 1. And so the graph of the cosecant, you just flip everything upside down. And that's all you do. So like over here, again, you're going to get that. And so you just flip everything upside down. Okay. So that would be the cosecant graph. When you're doing the secant graph, you just do the cosine first. So when you have y equal to cosine of x, your graph is going to look something like this. Okay. So that's y equal to cosine of x. And when you're going to graph y equal to secant of x, again, you just flip everything over. So over here, 1 over 0, you're going to get asymptote over here. So you just flip everything upside down. And then over here, just graph that. Okay, so that's how you graph the secant. Just graph the cosine first, and then you just flip upside down. Okay, now let's go to tangent and cotangent. So you got y equal to tangent of x, so that's a slope. So you have to graph the slope at every given point. Okay, so again, you have this graph right over here. So start at 0. So when x equal to 0, the slope is 0. Okay? When slope at 45 degrees, they just put over here, so that's 45 degrees. Okay? So at 45 degrees, the slope is 1. But when you get a 90 degrees over here, the slope is infinity, so it's asymptote. Okay? So basically you're going to get something that looks like this when it approaches infinity. And if you go backward, at negative 45 degrees, the slope is negative 1. Right? And so this is your negative 45 degrees. This is 45 degrees. That's your 90 degrees. So at negative 90 degrees, again, right over here, the slope is, again, is negative infinity, so you get asymptote. Okay? And then, so the graph's going to look something like this. That's where it came from. Okay? And so you do the same thing. So you keep going around the circle, you're going to end up with so you keep going around the circle. So again, at 180 degrees, the slope is 0, right? And so before here, this is going to be negative, right? See over here, like over here is negative 1. And right over here, the slope is positive 1. Again, we're looking at the slope. Okay, so that's positive 1 right over here. So again, if you connect enough dots, you're going to end up something like that. So it keep repeat itself. Okay. Now, if you're going to graph the cotangent, again, you flip everything upside down. So right over here is 0, so 1 over 0, you're going to get asymptote. Okay, over here is 0, 1 over 0, you get the asymptote. Now over here is infinity, so when you flip over 1 over infinity, you get 0. Okay? And over here, this is 1, so 1 over 1, you still get 1. Over here, negative 1, when you 1 over negative 1, again, you flip everything upside down, reciprocal, right? Over here, right now it's negative 1, so you put 1 over that. So 1 over negative 1, you still get negative 1. So your graph will look something like this now. Okay? And so it's going to be, so again, it's going to look like this. Okay. Again, over here, 1, so when you flip the 1 over, 1 over 1, you still get 1. So again, your graph's going to look like this. So cotangent is the orange one, orange graph. Tangent is the black graph. Okay. So you need to be familiar with yourself with the graph. So next thing you need to know is there are two terms. Okay, one is called the amplitude. Okay, the deviation or the height. So that's the A. So amplitude is the height. So in this case, for the sine function, the amplitude would be 1. See, like here, it's 1, right? It's always positive. Okay? It's absolute value. So amplitude would be 1. Okay? And the period, the P, period is how long it takes to repeat itself. So in this case, it would be 2 pi because it takes 2 pi to go around the circle, right? The reason it's 2 pi because it takes 2 pi to go around the circle. So for sine, to get to the exact same point is 2 pi or 1 circle. So all of them, so like this 4 right over here, the period equal to 2 pi. And the period equal to 2 pi. But over here, the tangent and cotangent, the period is equal to pi. Because what happens is, if you look at their slope, see over here, let's say when you get over here, right? So the slope is 1, right? Over here, the slope equal to 1. But what happens when you come over here? The slope is also equal to 1. But you only take pi, you only have the circle to get the same slope. So the tangent and cotangent, the period is only pi. You only take half of a circle to have the same slope. Whereas for the other 4 functions, you have to get to 2 circles to get exactly the same place. Even though over here is 0, but this is going down. So it's not the same point. Okay? So you have to wait until you get, see right now it's going up, it's 0 and it's going up. So over here the 0 is going down. So these two are not the same point. So right over here you have to wait until you get over here. So that's why it's 2 pi. Okay. So make sure you're familiar with all the graph, look through, okay?